All right, guys, what up? We're going to talk about synthetic division. Okay, we've talked about division of polynomials using long division, which is basically the same as long division of integers. We're just doing it with polynomials. Synthetic division is actually when we're dividing a polynomial by a linear binomial. Let's talk about what a linear binomial is, first of all. And the one we're going to be using in this problem, it looks like is x negative 6, okay? We know it's linear because this x isn't taken to any power greater than 1. If it was x squared, it'd be quadratic, x cubed, or x to the third, right, would be cubic. If it were x to the fourth, it'd be quartic, so on and so forth. So we have a linear because it's just x to the first. So it's a linear, and it's binomial because there's two terms, okay? So we have a linear binomial, and this is in the, because there's a value over here, right? And we'll fill that in a second. It's in the divisor position. Okay, if this were written as a fraction, we'd have some value n over x negative 6, right? Which would be the denominator position. Denominator position, right? Same as the divisor position. This is the numerator position, numerator, or dividend, right? When we get a solution, right, that is called the quotient. So equal sign solution, right? Solution to this fraction, rational number, percentage, rate of change, decimal, division problem, all the same thing, right? And the solution is a quotient. Top number is the dividend or numerator. Bottom number is the denominator or divisor, right? All right, so what will be in the dividend position is going to be x squared negative 4x negative 12. So we have two coefficients. In this case, the coefficient here is 1, and the coefficient here, the second coefficient, is negative 4, right? And we have this constant term right here. Now we're going to bring down the two coefficients, 1. And if you're confused about this 1, if it's x squared, we assume 1, right? Unless there's a 2 or greater there, we assume it's at least 1 x squared, right? So 1, here's negative 4, we're going to bring that down, and then we're going to bring down this constant negative 12, okay? Now I'm going to move these over just a little. So we have 1, negative 4, 12, and then we're going to make a horizontal line underneath them. And we're going to draw a little bracket, and I'll change the color here, this kind of right angle bracket. And in that right angle bracket, we're going to take the opposite of this constant term in the divisor. What's the opposite of negative 6? Well, positive 6, right? We're then going to drop the first coefficient, 1, and we will multiply negative 6 by this value, and then the product of that we'll write up here. So 6 times 1 is going to be 6, positive 6, right? At this stage, we will take the negative 4 and add it to 6. So we're at negative 4 on the number line, right? And we're moving in the positive direction, right? Positive direction, 6 places. That's going to give us positive 2. Okay? Now follow me here. At this point, we're going to take this 6 and we're going to multiply it by this positive 2. We're going to write that value right here. So that's going to be a positive 12. All right, positive 12. So if we have negative 12 and we add 12, that just brings us back to 0 on the number line, doesn't it? So that's a 0. That zeroes out. We have a nice even quotient of 1x positive 2. And you're going, whoa, where'd that x come from? Okay, when we do synthetic division, what we're going to do is we're going to drop each of these variables by 1 degree. So that x squared becomes just an x. This x to the first degree is gone completely, and we end up with just a 2, right? So we end up with 1x positive 2. The 12 zeroed out, and here's our quotient. Here's our solution. All right, let's take a look at another one. All right, so this one we're going to have a remainder, and you might remember remainders from when we were doing long division with just regular integers. Remainders we wrote r, usually period, and then some value, some value n, whatever the remainder was, right? We're going to do something real similar to that here. So we have, first of all, our first degree binomial, so a linear binomial. We have two terms, first degree, so it's linear, and it's a binomial. And it is in the divisor position, right? This is our dividend, right? And so we know that this is going to drop to a single degree x and that this is going to be eliminated, isn't it? All right? So our first step, we are going to go to our dividend and we're going to grab the coefficients. In this case, a positive 3, positive 5, and then the constant term, this negative 1. Right? We're going to then make a horizontal line. That's pretty terrible, not very horizontal. Let's try again, that's better. Okay, we then create our bracket. We take the opposite of the constant term in the divisor, right? In this case, negative 4, right? We then drop the 3. We're going to multiply this negative 4 times 3 and get a negative 12. So we have 5 minus 12. So we take it back 5 to get to 0, then we have to take it back another 7, we get negative 7, right? Now we go negative 4 times negative 7. That's going to give us a positive 4 times negative 7 gives us a positive 28, which we're writing right here. Right? So if negative 1, and we're going in the positive direction 28 places, we're going to have positive 27. Okay. Now, this gets reduced to just an x right here. And I'll put that in blue in case you didn't catch where I wrote that. There it is, right? This x is gone. So we have 3x negative 7, which looks real similar to our last solution, our last quotient. But we have this positive 27, right, coming from this dividend. It's still divided by x plus 4, so we have plus this extra 27 that still needs to be divided by x plus 4. So it is a remainder. That's what remains after our solution, right? So we have 3x negative 7 plus this 27 over x plus 4. There's our solution. Oh, that was a terrible circle. Sorry. Circle like this. Oh, man. Sorry, guys. There we go. Yay. Okay, so 3x negative 7 plus 27 over x plus 4. All right, cheers.